Hi, welcome to today's masterclass. My name is Lisa Richter and I will be your host today. On the off chance you don't know about CSIA, we are a global nonprofit trade association with over 500 member companies in 35 countries. For system integrator members, the CSIA Best Practices Manual and CSIA certification are some of the more popular member benefits, but you will also enjoy a variety of others, including professional development, learning from your peers, and access to professional services experts, including insurance, financial, and legal, who understand the SI's unique business needs. For partner members, CSIA offers an ecosystem to grow your SI programs, understand your customers' pain points, monitor industry trends, and share your thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. In case you aren't a current member, now is a great time to join. Membership provides you many benefits, including a full lineup of virtual events and other resources for you and your entire team, from accounting to sales to operations. If you are currently a member, thank you. Membership renewals were sent out to billing contacts last month. If you have any questions about the process, reach out to staff so you can continue to enjoy your membership benefits uninterrupted. At this time, I would like to turn it over to today's speakers. Take it away, guys.
Thank you, Lisa. And thank you for the opportunity to talk to your members today. Vilas and I are going to talk about how to improve project documentation and change management using automated tools. So I'm going to kick off and I'm going to talk a little bit about the background to this and why we think it's important. Then I'm going to pass back to Vilas, who's going to tell us in a little bit more detail about some of the features that are important in these automated tools and the things that can help you in your projects. So I'll introduce myself and I'll let Vilas introduce himself when he comes on. So my background is I'm an automation professional. I've been in the business for 33 so years now, and I'm originally from the UK, but I'm based in Houston, Texas now. And I do a lot of work in these days in industrial cybersecurity, but I also do various automation related projects. And that's where my interest in this particular topic comes from, because if you're like me and you've worked in an automation related project, you know that this documentation stuff can be a real challenge, and finding ways to make it better is always our mission. I'm also currently the immediate past president of ISA, International Society of Automation, and we're going to be talking a little bit about them and their standards and how they play a part in this as we go forward. So the background to this is that I met Vilas because he'd been working on a tool to help projects with documentation and change management. And I was interested in it because at the time I was working on a major capital project, still am in fact, and have been working on other capital projects in the side and also prior to this one. And every project that I worked on always had the same challenges. The things like, how do you get the documentation produced quickly and efficiently? But more importantly, how do you make sure the quality of the documentation is good? How do you make sure that the different documents that relate to a particular project are aligned? And so that, you know, if you find one thing in one document, does it match what it says in another document? How do you correct those things when you find those mistakes so that someone can open a document and be confident that the information is correct? And then also, once you've done that, then inevitably in every project and in operations, you're going to change this stuff. And how do you find a way to make that change process efficient as well? So we wrote an article which is in ISA's Intech magazine. We wrote it back in, it was published in the April copy of the Intech magazine. And if you haven't read it, then it's still available online. The link is there. And what we're going to do here is talk a little bit about basically what was in the article and why we think using tools and using standards are important in this process. So I'm pretty sure everybody who's on the line will agree with all of these points. The first thing being that It's expensive and time consuming to produce documentation. And in fact, as a result of that, often people look for shortcuts, unfortunately, and projects suffer as a result of that because it takes longer to complete projects because it's harder with the inadequate documentation, and then handing over those documents to operations and then asking them to manage a facility or whatever it might be for 10, 20, 30 years with poor quality documents is a major problem, and a very costly and time consuming problem for them as well. The quality varies, so it's very much dependent on individuals involved. Especially if you don't follow standards. So it's the information and the quality doesn't transfer very well between projects, between customers, and between countries, for instance. And there are tools available, but it's how you identify the requirements for the tools and how you use those tools appropriately that's important here. But certainly, if you centralize the content, the information that's used in projects, I think that regardless of what tool you use, and we're not here to talk about specific products here, we're talking more generally about the concept of using tools and standards. But whatever tool you choose, the most important thing is to centralize all that information. So it's in one place. There's a single record of the truth that you can use to produce all the documentation you need. And I would definitely recommend as well that not only that single instance of the truth is where you get the information, but you should definitely strive to produce the documentation from that rather than produce documents and then have to try and align it with other sources of information, because that's where errors creep in and that's where problems occur. And like I said, change management is a big issue because projects inevitably will have changes. You can't expect that at the beginning of a multi-year capital project that nothing's going to change. The customer's going to come up with new requirements. You can identify issues that weren't in the early stages of the feed, and you're going to have to make changes to that document. And how do you manage that in a structured and organized way to reduce the cost of the change itself, but also any errors that might creep in? That's really important too. So yeah, and then finally, as I said, standards are really important because we want to be able to take what we've done in one project and transfer that knowledge to another project. We want to be able to have people who can take up projects for different customers and different sectors and different parts of the world and be able to get up to speed very quickly with that. And standards are one of the things that can help with that. So what are we saying when we're talking about documentation? What do we mean by project documentation? So the kind of things we're thinking about, we've listed here. You've got instrument indexes, things that typically some kind of database that has all of the instruments that are in your design that you might have, everything that's in the PFDs and the PIN IDs. Then you've got things like junction box schedules, so things that identify how many junction boxes you have, how many terminals they have, what type of construction it is, where the cables go, all those kind of things that you can specify for junction boxes. The cable schedules, where, how many cables, how many cores, length, all those kind of criteria there. Wiring diagrams, so how all of these things go together, the instruments into the junction boxes, the marshalling racks, the control panels, the I/O connections that you might have for the instruments. Terminal diagrams, so specifics about which wire goes to which terminal inside which junction box, marshalling rack, and control panel. And then you've got things like device data sheet specification forms, so providing all the information about a particular actuators and instruments that you would have. Help, all the kind of things related to procurement, but also the calibration details and operating conditions and such like. Then you've got details about your particular DCS or PLC I/O configuration. So critical to be able to make sure that you do all the connections right, associated with the right PLC and DCS programs. Then loop diagrams and hookup diagrams. So all things to help people both build these things in the first place and also maintain them going forward. So lots of different types of documentation, but they all originate from a common source of information that you should be able to put together And like I said a moment ago, if you do produce all of these documents from the same source of information, then you're off to a great start, because now you know all these documents are going to be at least consistent within themselves. And if you make a change to any of them, making a change to the source information itself, and so any other document that's associated with that source information should be able to be updated very easily. So, as I said, we're not talking about specific tools here, but I've picked a couple of examples of the types of tools that I've seen used on projects. So they vary in scale and complexity and capability, from simple tools like basic Excel itself, to produce lists, spreadsheets of instruments and lines and vessels and actuators and whatever else you might have in your facility. That for a certain size of project, that's more than adequate, and there's absolutely no reason why you shouldn't use that. One of the advantages of using a tool like Excel is that the skill level is relatively low. You don't need to be an expert CAD person to be able to drive Excel. People use it all the time for all kinds of other things these days. So putting a list together in Excel is not too difficult for most people. So it's great from that point of view. Problem is, obviously, it's not as scalable as some tools might be. So there are limitations in Excel in terms of number of rows you can have, and it can get unwieldy if you're dealing with large amounts of equipment, large numbers of junction boxes, wires, terminals, and things like that. So certainly not advocating that Excel is the solution that everybody should be using just because it's easy to use, but it is got some interesting capabilities, but it's certainly not scalable for very large projects. But then the other piece of this, the third piece of this that we would recommend, is that centralization piece. So however you produce and manage your information, it really needs to be centralized for it to be as effective as possible, and to be the quality to be maintained as much as possible. So that's also one of the challenges with tools like Excel, because you could have spreadsheets, you can have individual spreadsheets for instruments, some for valves, some for lines, and then different people could maintain those. And yes, you can put those spreadsheets on central facilities like SharePoint and other things, but managing those and controlling the versioning of those can be challenging. You probably want to look at a tool which has some kind of database behind it where you can put all the information in, and then everybody manage that content of that database from some central or some distributed application that allows you to access the database in a shared way, and to make changes and to have those changes made in a multi-user way, and also in a version controlled way. So, the example we got there is something like AutoCAD, which is much more comprehensive than something like Excel, has more of that scalability, more of that centralization built into it. So that's also attractive for some people as well. But one of the challenges there, again, is that it's requires a higher skill level than something like Excel. So, you have to think carefully about how easy it is to use tools like that, how much training people have to have in order to use it, and therefore how easy it is to distribute the use of that across lots of different people. One of the reasons being, of course, that if it's hard for people to use the tool, then they might find a different way to either create or manage the data. And then that creates your data quality problem again. So you do want to try and have a tool that everybody can use. So the next thing is standards. So hopefully everybody on this call understands the importance of standards. They're the thing that really helps us in the automation profession make sure that what we do is consistently done to the right quality, done to the right levels of safety and security, so that we know that when we produce something and follow a standard, that we've done the very best that we can for the customer, and for the customer's point of view, they know they're getting something that meets all the expectations in terms of best practice, such like. So ISA, of course, is a well-known in the automation profession as a standards development organization. So it's ANSI accredited, ANSI being the American National Standards Institute, and it produces a whole suite of standards which are very important and very fundamental to the automation profession around the world. And they also do other things. They do training in things like the standards and how to use them. They do events related to standards and content related to those standards and automation related topics. And they've been around for more than 75 years now. In fact, it was the 75th anniversary just a couple of years ago. So if you're not aware of ISA and its role in those standards, you will almost certainly, if you do any automation related project, be using one or more ISA standards, but you may not realize it. So I picked these three standards here, which are very applicable to the documentation that we're talking about in projects, because these are really fundamental, and you will, if you, as I said, you might not realize it, but you're actually using these standards as you produce the documentation for a particular automation related project. So ISA 5.1 is about instrumentation, symbols, and identification. So this is a standard which defines a uniform way of defining what symbol means which piece of equipment, and how you use the terminology around that, how you use the markings on that drawing for people to consistently understand what's being said in that drawing. So really important fundamental standard for automation, so that someone can pick up a P&ID, for instance, and immediately understand what that is telling them. Then the second standard about instrument loop diagrams. So this defines the requirements that are needed to produce a loop diagram and how to produce a loop diagram. So again, if you're going to produce a loop diagram, or you're going to ask someone to produce a loop diagram, this standard will allow you to make sure that you can easily, categorically, and consistently and reliably say what it is you expect to be included in that loop diagram. And then finally, we have ISA 20, which is the standard which defines the specification forms for instruments and primary elements and control valves. So this is the like the instrument loop diagram one, this is something which tells you what you would expect to see in an instrument specification, for instance. So again, that you know when you ask for that, that it meets that requirement, and also as a customer, for instance, you can use that to specify equipment that you need on a particular project. So if you're not familiar with these standards, there's a link there. Again, you can go to the ISA website and read more about those standards. And if you're an ISA member, you can have read-only access to view all of those standards as well. So benefits of standards. Well, I think I've touched on some of these already, but just to recap, it's got the combination of a whole host of subject matter experts from different sectors, different parts of the world, who've come together to combine their best industry practice that they follow, so that you can help define, design, develop, integrate, and produce all the documentation you need for an automation project. And then when you're specifying something, using these standards allows you to have a common language, if you like, about what you expect vendors and other collaborators to do to provide that either product or the specification for that product. So the terminology, we get consistent with that. So when we talk about a particular type of device, we know we're talking about the same kind of thing. So it really helps with specifying, quoting, and purchasing equipment. And then ultimately, the standards themselves may take a long time to produce because they're collecting all that knowledge together. But once they produce them, it becomes very much more efficient to for projects and for users of these standards to actually produce consistently and high quality solutions. So the requirements then, since we talked about all those things, to have an automated documentation process or tool, we need it to be scalable. We need it to be something that can both work at the small project level, where it's easy to use and everybody can use it without having extensive training, but also to be able to use the same tool to scale up to very large projects, so you don't have to have multiple types of tools around. You need to centralize all that data so that you're using one source of truth to produce all the documentation, or as much of the documentation as you can, from the single source of information. And when you change any of that, you're changing it in the central location so that any changes get reflected in any of the documentation that's produced automatically. Like I said, it needs to be intuitive. It needs to be easy to use. It shouldn't require years and years of training and very specialist skills. That can be expensive and also hard to find the right people. And then you need to use those standards. So you need to base it on the standards. You need to be able to produce the output documentation to the standards, and so that you get the right quality output in the end. So if you use tools, then the benefits should be obvious. I mean, if you use the centralized automated tool, which is easy to use, you can execute projects much more efficiently. So you're talking about less effort, you're talking about lower cost, you're talking about maybe not having to have expensive, highly trained people in some cases to do things, because the tool can do a lot of that stuff for you. And also, even on a small scale, you can save quite a lot of time and effort. But as projects get bigger and more complicated, using the same kind of tool can exponentially increase the efficiencies that are associated with just producing the documentation in the first place, but also managing that change process as you go forward. So that's what I wanted to introduce here. So now I'm going to hand over to Vilas, and I'm going to ask him to tell us a bit more detail about how these tools might work. So Vilas, over to you. If you could introduce yourself and then tell us about that.
Sure, Steve. Thank you so much. And thank you to Lisa and Jennifer also. And thank you everyone for joining us in this webinar on automated tools for doing instrumentation engineering, right? So let me just walk you through a tool called as PlantVerse that gives you all the information that Steve just talked about. So let me introduce my screen to you. Yeah. So I guess this is visible. Steve, is this visible, the screen? Can I go ahead with this?
Yes.
All right. So this is basically about a tool called as PlantVerse, which is used to do the documentation for instrumentation engineers. And it's very simple to use. You begin by addressing the client that you want, and either you could create a new client or you go to a client which is existing. Let's take an existing client. The purpose of this demonstration is to signify or highlight the importance of using standards, and also to bring about the change management, how easily changes can be done by using an automated tool. So you first set up your client by using the screen, and then you quickly go to the configuration. So as I walk you through the tool, you would be seeing a lot of ISA standards that are being used in the tool. So we begin by saying that the instrument tag as well as the process element, they are all based upon the ISA standards. So this is where we begin talking about ISA standards right from addressing your clients. So after you set up your clients, the next thing that you would like to do is to set up your project also. Now, before we go into the projects, as Steve said just now, you can use one of these three radio buttons to work on the size of the project. If your project is small, you can use this button. For medium-sized projects, you can use this button and this button for the large projects. So let us now quickly go to the projects. Uh, and here you would assign a new project, or you would open up an existing project. So you open up an existing project over here and then mention all of the project details in this screen. So when you update the project details, you are automatically navigated from one tab to another tab, right? So we update the project screen, and then we navigate to the list of measurement. Here also we are going to use two systems of measurement, either the MK system or the CGS systems. So you configure all of your measurement systems here, and then when you update this, you go to the uh, next screen, which is called initial process parameters. Now, all of these process parameters, the values that you enter into these process parameters are copied into the data sheets and also into your instrument index. Now, when you come out of this, you will be automatically navigated uh, to a PNI diagram. Now, this is where the project begins. The user typically uses a PID diagram to populate the database of the sort of the automated tool. So let's say that we begin with a PID called as PID 01. You could add a new PID also, or you can work on existing PID. So this PID will be having a few loops over here. You can open up the loops or you can add a new loop, and you would find in this loop there are various devices that are seen in your PID diagram. So one of the devices, for example, can be a level transmitter, and you can add more. You can do the change management of the tool that of the instrument that you're working, or you can also add up a new your device into this. Now, instead of going to this project, let me also walk you through a more comprehensive project, which is the one that we are selecting over here called as sulfuric acid regeneration. So with this, you would find that there are a lot of more loops, and all of these loops will have different items. So you can open up, this loop is having 5 items: conductivity meter, temperature sensor, flow, level, and pressure sensors. So you can configure all of your meters, all of your device over here, and you would see that we use the second level of ISA standards when you are going to configure your loops, right? So you either select a primary or a secondary device, and then the moment you select a device, you would observe that the ISA codes are generated automatically, and the element tags are also generated automatically. And this is what Steve was precisely mentioning about the advantages of using automated tools, which does most of the jobs automatically, leaving very little room for making errors, right? So once you configure your process element, you go to the next screen and you will be guided to an instrument which is being associated to the element that you just selected. You enter all of this information on the left side, and you'll observe that the ISA code again is generated automatically. So you could build up your project by using these screens. And if you navigate further, you would see that this instrument would be connected to a junction box like this. So it's connected to a junction box. Now, by doing this, you are going to populate all of your devices just the same way that we did over here, right? So once you populate all of your devices, the automated tool would take you to a screen which is called as records. Here you would find all of the instruments that you have used in your project being listed out. Now you can use this this index to create all of your documentation automatically one by one. Now, the very purpose of using ISO standards, as we all know, is to have an uniformity in the drawings and documentation that you have for every equipment in your plant. Just in case you think that you have more vendors giving you different kinds of equipment, you would be in a position to quickly identify all of the devices throughout your entire plant instead of having different symbols and different terminology for different equipment. So we would find that all of these instruments, once they are located in a centralized place, you would get to see each of the documentation that comes along with this. The first documentation, as Steve said, is instrument index. Then you are having junction box schedule, you have the cable schedule, you have the loop diagrams, and then the termination diagrams also. Besides this, the automated tool will also expose you to the more information like the PLC DCS IO counts and the junction box consolidation. So let me walk you through all of these documentation one by one, just to give you a perspective of uh, how documents are done automatically by using uh, tools like PlantWorks. The first on the screen is the instrument index, where you would find all of the instruments listed over here. You would also be able to do some manual editing for the location or for any other uh, parameters that you want to set. And you also have the provision of adding a few more fields like user-defined fields, right? The next output this output can be exported to an Excel by using this button. So you get all of this information in the Excel also, which you could preserve and carry to your site for doing any changes that you want to do. The next output will be a junction box schedule where you have a list of all the junction boxes in your project and the way they are wired, the signals that these junction boxes are carrying, and all other information about the manufacturer, the model, and so forth. The next output would be a cable schedule, which should be more interesting because of it's very difficult to draw cable schedule into an Excel. You would not have you would go through a pain of making many changes if you use an Excel tool. But with an automated tool, you can just have formulas like this, which will give you the cable identification for the junction box as well as the marshalling rack and the control panel also. The next one is loop diagrams, as Steve was mentioning, can become very complicated if you don't have all the information stored in a centralized location. Now, this is a very typical loop diagram, but the automated tools can also give you the flexibility of having different templates of the loop diagram. Here you would see all of the information that is being presented is done automatically. So you don't the user doesn't really have to look back and see if something is wrong or something is right. Further, you have the termination diagrams for the junction box, the marshalling rack, and the control panel. But before we do that, let us see the loop diagrams can also be sent to the PDF format, and the junction box schedule and the cable schedule can go to the Excel format also. So this information can be easily exported to Excel. The next thing that you would like to see is the termination diagram. In the termination diagram also, the diagram gives you a list of all the terminals that you've used inside your panel for different panels or for different junction boxes and even the marshalling rack. Now, this information also can be exported to PDF format. Now, the other document that comes automatically by using such a tool is you can have PLCs and the CSS IO counts listed over here based upon your control panel and also based upon the controllers that you're using inside a control panel. This information can also be exported to Excel where you can manipulate or you can add some more input and output counts coming from your MCC or other areas. Then you have a junction box schedule also, which gives you the number of instruments connected to any junction box, along with the number of terminals used in that junction box. And the tool also gives you the option to use some spare terminals or other terminals that you want to have. So in short, this is how an automated tool would work, and you would also look at having all of this documentation coming in the form of either Excel or the PDF. Now, Steve was also mentioning to you about the importance of doing changes. So if, for example, if you don't want to have a particular equipment or you want to change it with something else, like don't want to have a conductivity meter and you would like to have something different, you can use this button and change it immediately. So any changes that you make over here is going to be reflected immediately across all the documentation. Maybe let us take an example of using a density meter instead of a conductivity meter, and you would see automatically the ISA code getting changed. You would also you don't need to do any changes in the wiring. So then you come over here, don't want to change the junction box either, and you say you're done with the change. You would see that this change is reflected in all the documentation. So instead of a conductivity meter, you have a density sensor over here. So this way, the changes must be done instantaneously and accurately. Now, this reduces more than 60 to 70% of the project work because most of the time that an engineer would spend is in doing the changes. So in this way, all of the changes can be incorporated. You could also do the changes in assigning your marshalling rack or the control panel or even the controller to the instrument. So for example, if you don't want to connect this instrument to a marshalling rack numbered as 49, you could as well connect it to a marshalling rack, say, marshalling MR50. So it will get connected immediately to to this. So all of these records are updated automatically, and then you see the same change being reflected in all of the documents that are being produced by the tool. So this is how an automated tool would look like, and this is where we are going to use lots of ISA standards. One of the most important places where you would see the use of ISA standards is in the instrument index. If you see all of these tag IDs, they are based upon the ISA standards, ISA standard 5.1. Further, you could also use ISA standards for getting all of your data sheets. So if you want to have a data sheet for one of the item, you could say for a density meter, have a data sheet. It would look something like this. You could download a template. It is not available, so let me download this template. Yeah, so you could see an instrument data sheet coming over here, being downloaded. Now, I'm not sure. Okay, yeah, this is the one that you would see as a template for the density meter. So all of this, the data sheets that you find over here with this in the automated tool is catering to ISA standards. So everything that the software will show you is catering to the ISA standards. I guess that is all I wanted to show for this small demonstration. And Steve, are you sure you have said everything, Steve?
So he must have popped off, but I do have a few questions in the Q&A that I will try and field for you. Again, this is a foreign language to me, so I'm just going to literally read the questions to you and hope they make sense. So we have one question that says, is there a specific form that states the ISA standard to create the proper wire tags on the loop drawings if customer does not have a standard? And then it says how to handle instrument data sheets. I hope you know what that means because I don't.
Yeah, Steve, you would like to take that question or?
Yeah, you go. Yeah, I mean, I'm not sure if you, yeah.
Okay, so the first question, Lisa, can you repeat it for me, please?
Sure. Is there a specific form that states the ISA standard to create the proper wire tags on the loop drawings if customer does not have a standard?
Okay, there is, in fact, for doing the cabling or in fact for doing the wiring diagrams, there is no ISA standard that says you need to do it in this manner only, but all of your cable diagrams and wiring diagrams will include the elements tags, tag IDs, which cater to the ISA standard, which follow the ISA standard rather. So there is no particular format, but you could always use the ISA standard into your wiring diagram or cable diagram. And what is the second question, Lisa?
How to handle instrument data sheets.
So the way the instrument data sheets are handled again depends upon the automated tool that the user wants to use. In this particular tool that we just saw, the way the instrument's data sheet is handled is you can either upload a data sheet that you have of your own. For example, you may follow certain standards of using your data sheet, or the software tool will also provide you a data sheet that is exactly in line with the ISA standards. The data sheets that I was just wanting to present to you are all catering to the ISA standards.
Could you do me a favor and stop sharing your screen? Because I'm looking at myself. It's getting very meta for me. I appreciate that. Thank you. And then we have, so as a reminder, guys, if you could please post your questions in the Q&A feature. You're more than welcome to use the chat to chat amongst yourselves, but I can't monitor both windows at the same time. I'm just not that coordinated. So if you could please put your questions in a Q&A, that way I have everything in one place and I can make sure that they get addressed in a timely fashion. So the next question I have for you, are the exported files from this system importable to AutoCAD Electrical?
Yes, you could. There are two ways that you can do it. If you want to export all of these drawings into the AutoCAD, the information that comes to you right now is in the PDF format, especially the drawings. So you can always use a third-party tool to convert from a PDF to an AutoCAD, or we could also give you the information directly into the AutoCAD itself. That should not be a concern. The automated tools can do that perfectly.
So somebody's put in the chat, is this program like SPI?
That's a very important question, but let me not make any claim saying that this is same as SPI or any other tools that is available in the market. But It provides you all of the information, all of the outputs that you want to typically use in your documentation. Okay, so it does all the job that an engineer wants, but let us not compare it with any other tool because the way it works, it's quite different.
So this one says, is this software support Power Plant's KKS standard?
I would say it doesn't do that because the software is not meant to do that. It is meant to produce the documents in accordance to ISA standards, right? So we only follow ISA standards for all the documentation that needs to be, that an engineer would require.
Steve, did you have anything else to say, or did you want to pop back on for any reason? I don't know if you had like maybe some slides or context. Oh, wait, we have another question. Does the software able to support to ePlan the way it does to AutoCAD, or is there a file you have to send?
Okay, the integration to the integration for the ePlan is on the way. That will come up very shortly. So you could import and export the information directly into the ePlan.
Awesome. So I'm going to turn it back over to you, Steve. You can take it from here. I'll pop back on at the end to say goodbye to everybody, but I'm going to go dark for now. Thank you.
All right. Thanks, Lisa. And thanks, Vilas, for that explanation. And thanks for answering the questions. Yeah, hopefully what you saw today was good discussion about the use of tools in producing and maintaining project documentation for automation projects. And as we said, many different types of tools out there. You mentioned in the questions about SPI being an example. There are lots of other tools out there, but the important thing is we want to encourage the use of two things. We want to encourage the use of standards, especially ISO standards, because they form the foundation of reliable and high quality information that you can have in projects. And then also the use of centralized based automated tools, because it's not just about the cost saving and the time saving that's associated with it, but it's also improving the quality and reliability of the information and the documentation you produce. So I'd like to thank you for taking the time to sit with us today and talk about it. And hopefully, if you have any interest, then contact details are there, and follow up and look at the Intech magazine article from April, which is online, if you want to read more about it. So thank you again to Lisa and and everyone for allowing us to take your time today to talk about it.
So if you do me a favor and pop that contact info in the chat, Steve, that would be awesome.
Yep.
And we are going to share the recording, and if we have permission from the panelists, we'll also share the presentation.
Sure.
Happy to do that. And next we're going to do my little wrap up. So my colleague Jennifer is going to pop up my final slides here. On behalf of CSIA, I would like to thank our speakers for this informative discussion. Of course, thank you for attending. I'd also like to remind, I just said the recording was going to be available. I'm repeating myself there. And be sure to bookmark the CSIA events calendar so you don't miss any upcoming events in the new year. One last thing, be sure to check your spam folder for any CSIA emails you might have missed. Even better, whitelist CSIA so you can stay up to date. This concludes our program for today. Once again, thank you for joining us and have a great day.
Thank you.